Now we get on to naming covalent compounds. One thing to remember is that because electrons are shared and they're not transferred like an ionic compound, there is no swap and drop. So before we would look at the periodic table to get the charge of the cation and the charge of the anion, swap those charges and then bring them down or drop them as subscripts. That's not going to work anymore because they're not transferring electrons. However, the name itself is going to tell us how many atoms of each element there actually are. And so what we're going to do is we're going to use these Latin prefixes to tell you exactly how many atoms of an element there are in a chemical formula. And for most cases in our covalent compounds, this system is going to work. Now the Latin prefixes are as follows. So here on the left side, this refers to the number of atoms. Okay, and based on the number of atoms, we figure out the appropriate prefix. Now, a prefix means that it goes before the element name. So I'm going to write before and then element name. Okay, and so the way this works is, if in your compound you have one oxygen, you're going to put mono in front of the oxygen. Okay. If you have two oxygens in your compound, you're going to put di, and this would become dioxide. And the di tells us that it has two. If, for example, you have, let's say, 6, then you're going to put hexa in front. And an example of this would be if we have a compound that has 6 fluorines. So let's say it's F and there's a subscript 6. Well, this would be then hexafluoride. And normally I would put this all together, but I just ran out of room on the side. So hexafluoride, and the name hexa tells us that it has 6 fluorines. So finally, before we get to some practice, we're going to just list a couple of rules here, and then you'll see these rules exercised in the examples that we're going to cover. So we never use the prefix mono for the first element. Now you can use it for the second. In fact, you should use it for the second element in the compound, but for the first, we never use mono. We just name the first element as is. However, if we need to use other prefixes like di, tri, if there's 2 or 3 atoms of the first element in the compound, then you use those. But you just never use mono specifically. It's kind of just an exception. The second rule that is worth mentioning is that the second element uses all the prefixes, including mono, and it has a suffix, right? It ends in "ide." So let's say there are 2 oxygens. It'll be dioxide, so dioxide. And the IDE tells us that it's the second element in the compound. Last thing, and I didn't really write it down here because it will kind of go without saying, but these rules really only apply to, we can call them binary covalent compounds, which is really when they just have 2 different elements combined to form this compound. If there are 3 or more different elements in this compound, then this naming system doesn't apply, and usually, it's an organic molecule or a sugar, etc. So let's get practicing. Okay, so hopefully you've had a chance to try this one out. Again, using all the rules, we have sulfur, and again, it only has 1 atom, and it's the first element, so we're not going to put mono. Sulfur hexafluoride, and the hexa refers to the fact that the fluorine has 6. So now what we're going to do is that we're going to go backwards. So we're going to go from the name, using the Latin prefixes, to the chemical formula. Unlike ionic compounds, we don't have to swap and drop, but the name is going to tell us exactly what to do. Okay, so we're going to write the chemical formula for the following. So carbon monoxide. Now remember that if we see no prefix in the first element, that's because there's only 1. So we're going to just write carbon over here, And then we see that the second element in the compound has mono in front of it. And if you look at the chart given here, mono refers to 1. So we're just going to write 1 oxygen. And so the formula, using the names, would be carbon monoxide. So this one's a little different because we go from the formula, from the name to the formula and work a little bit backwards. Now, let's say if we look at the second one, we've got nitrogen. Once again, if there is no prefix there, that means that it is just 1. So we're going to write nitrogen. And then it says trifluoride. Now, tri means that there's 3 atoms, and fluoride tells us that the final element is fluorine. So we're going to write N, and then F for the chemical symbol of fluorine, and then a subscript of 3 as indicated by the tri. The last one that we're going to do here, and I want you to try and do this one yourself. So once I write it down here, I want you to pause the video, try it yourself and see if you got it. We're going to try, I'm going to erase this here. We're going to write diphosphorus, and then pentachloride. So diphosphorus, pentachloride. Or we can give a more realistic name. Actually, pentoxide is more common. So diphosphorus pentoxide. Okay, so give yourself a minute, look at the chart, and see if you can come up with it. So hopefully by now you've got some form of an answer. So the diphosphorus, when we look over here, we see that the first element would be phosphorus. We'd put a subscript of 2 because under the di would be 2, and then penta would represent 5 elements of oxygen. So putting it all together, it would look something like this: P2O5. So that sums up covalent compounds in contrast with ionic compounds. And what I want you guys all to do now is to practice. Getting used to writing formulas both for ionic and covalent requires practice, and the more practice you do, the more efficient you will be.